Here in the 1970s, astronomers studying the leftover light from the birth of the universe, known as the cosmic microwave background, discovered something remarkable. Our galaxy, and everything in it, including you, is hurtling through the universe at an astonishing 390 meters per second. That number is almost impossible to put into perspective, so let me just say this: since you started watching this video, you have physically traveled more than 11,000 miles. And you thought you were a couch potato. Accurately measuring the speed of our galaxy for the first time was a big deal, but it was also a little bit scary because nobody really knew exactly why the Milky Way was moving quite so quickly. A big chunk of our velocity could be explained by the expansion of the universe, which causes all astronomical objects to move at rates described by something called the Hubble flow. Some of the rest was accounted for by the interplay of gravity between the Milky Way and our nearest galactic neighbors, like Andromeda. But something was still missing. We appeared to be moving at a speed and in a direction that we just couldn't quite explain. It was almost as though our entire galaxy was being dragged off course by some vast, distant object. That was disconcerting, to say the least. But there was more. It turned out it wasn't just the Milky Way that was being pulled towards this mysterious unseen object, it was everything. Every single galaxy in our little corner of the universe, around 100,000 of them in a region spanning more than 500 million light-years, is being pulled inexorably towards the same unknown thing. No longer just disconcerting, that was downright terrifying. Using powers of creativity that we can still only marvel at today, astronomers decided to call the mysterious object the Great Attractor. But coming up with such an ingenious name was the easy part. The hard part was determining just what the hell it could possibly be. There's only one force in the universe capable of nudging entire galaxies off course over distances of hundreds of millions of light-years: love. Sorry, I've been listening to a lot of music lately. What I meant to say is gravity. Gravity is created by mass. The more mass an object has, the stronger the gravitational force it exerts. In order to attract 100,000 galaxies over a distance of hundreds of millions of light-years, the Great Attractor has to be big. And when I say big, what I really mean is unimaginably, mind-bogglingly, rules of the universe breakingly colossal. The question is, what is it? And more importantly, what's going to happen to us when it finally reels us in? Let's start with the first question. We typically learn about distant objects in space by training our telescopes on them and having a good look around. But just to amp up the mystery even more, when astronomers first tried to probe the Great Attractor with their trusty telescopes, they quickly realized that wasn't going to work this time. The Milky Way is a spiral galaxy about 100,000 light-years across, and its 100 billion or so stars are concentrated along a plane 1,000 light-years thick. Unfortunately, whoever built this place seems to have left a lot of crap lying around, because when we try to peer into deep space through the plane of our own galaxy, our view is almost entirely obscured by vast clouds of interstellar dust and gas. This section of the night sky that's occluded by the plane of the Milky Way is known as the zone of avoidance, and it obscures our view of about 10% of the universe. And you guessed it, the Great Attractor just so happens to lie smack bang in the middle of it. That's why, for several decades after the Great Attractor was first discovered, its true nature remained a total mystery to us. We could only study it indirectly by measuring its gravitational impact on the galaxies around it. It wasn't much to go on, but it did allow us to determine the Great Attractor's approximate location, between 150 and 250 million light-years away in the direction of the Norma constellation. And for the first time, we got a hint at its massive size. According to our current best estimates, the Great Attractor contains mass equivalent to 10 quadrillion suns. At the time, that number just didn't make any sense. Nothing in our universe is even close to being that size. As of today, the biggest single entity ever discovered is an ultramassive black hole called TON 618. And it's so absurdly enormous that part of me suspects those pesky astronomers might have just made it up for a laugh. This behemoth of a black hole is almost 250 billion miles across, and it powers a quasar that burns with the light of 140 trillion suns. It may well be the biggest thing that has ever or will ever exist in our universe. It is an awe-inspiring, terrifying nightmare of oblivion incarnate. And yet, it's estimated to weigh in at just 66 billion solar masses, not too shabby as far as black holes go, but still around 150,000 times less massive than the monstrosity that is the Great Attractor. Incidentally, scientists may have recently discovered an even bigger ultramassive black hole, Phoenix A, with around 100 billion solar masses, but there's still some debate about its true size. Anyway, whichever is larger, the question remains, if the biggest thing in the known universe is nowhere near massive enough to explain the gravitational effect of the Great Attractor, then what the hell can? This is usually the part of the video where I tell you that, for the time being, we have no idea. Except this time, we actually do. As I've already mentioned, it's almost impossible to directly study the Great Attractor using regular telescopes, that is to say, telescopes that gather light predominantly from the visible part of the spectrum. But visible wavelengths aren't the only ones available to us. And in the 40 or so years since the Great Attractor was first discovered, we've made huge leaps forward with both radio and infrared telescopes. With the help of these new technologies, we've finally been able to peer through the zone of avoidance to catch a few fleeting glimpses of the patch of sky that contains the mysterious and enormous Great Attractor for the very first time. So what did we find there? The universe's most morbidly obese black hole. An intergalactic megastructure built by an advanced alien race? Kanye West's ego? Sadly, no. What we actually found was more galaxies. Loads of them. Okay, so that might sound like a bit of an anticlimax. But seeing what lay beyond the zone of avoidance finally helped us to understand the true nature of the Great Attractor. And it wasn't what we'd been expecting. To explain what it was, we need to go on a quick journey back to the beginning of time.